Okay, first lesson of chapter 8 is reviewing the Pythagorean theorem. So you have done this before, but we want to make sure that you've got it down pat. It's important when working with right triangles, and that's what this unit is all about. So in the try these, it's just calculating some expressions. Some have exponents of 2, some have square roots. Okay, it says, if necessary, round your answer to 2 decimal places. Well, the first one isn't going to be rounded. It's 21 squared, which is 21 times 21. You can use your calculator. So get out your calculator, 21 exponent 2. So exponent key squared. And so 441. Some of you might have a squared key. So for the next one, let's use that. So that's 3.2, and the squared key on this calculator is here. Then plus, oops, did that twice, plus 2.3. Oh, my computer doubles up, 2.3 squared. 15.53. Then the next one is square root. So that is, on this calculator, we have to go the second key and the x squared key. So that's the square root of 12. If you have a scientific calculator then that doesn't show the square root symbol, then you might have to put 12 in first and then press the square root key. So that's 3.46 when we round it. And then in the next one, if you have a graphing calculator, you can put it in as it's shown. So 9 squared minus 4 squared. That's what it said, yep. And so you can just enter on that, 8.06. Now, some of you might think, oh, well, square rooting is the opposite of squaring, which it is. And you might go, oh, that's just 9 minus 4. You can't separate the radicand up into terms. So you have to, it's like order of operations. You have to do the brackets, the underneath the radical sign first, and then square root it. Okay, so be careful of that. If you have a scientific where you can't see the square root, then you might have to do that 9 squared minus, oops, I squared it twice, 9 squared minus 4 squared first, and then take the root of 65. Okay, and you'll get the same answer. All right, so back in junior high, you probably did something similar to this. Marie, Pierre, and Sam are doing a bottle drive for their hockey team. Marie, Pierre will go to the houses in region A and B, and Sam will cover C. Will they cover the same number of blocks? How do you know? So if we count these up, so this has all been measured out, equal blocks, then A has 9 of them, 3, 6, 9. B has 16 of them, 4 rows of 4, and Sam has 5 rows of 5, which is 25. Well, 9 plus 16 is 25. So actually, they will go to the same area of houses. Yes, as the total area for Marie Pierre is equal to Sam's area. How many units long is the side opposite the right angle? So here, notice how it forms a triangle inside here, and the side opposite is how many units? 1, 2, 3, 4, 5. 5 units. So we can count them up, but if you take a look at the measure of the smaller triangles, okay, you'll see that they will be related to each other. That's actually going to come up in the next thing. So 5 units, we can measure it, but really that's equal to the square root of 25, the area. Okay, so there's a couple of ways of finding that length of the triangle, of the hypotenuse. Okay, so here's the diagram again, basically. So in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides, which we call the legs. So these that form the 90 degrees are the legs. They keep the triangle what it's supposed to be, just like we stand on our legs. And so they are related by this formula, which you learned already in junior high, a squared plus b squared equals c squared. And that's the Pythagorean theorem. So it was named after the ancient Greek mathematician Pythagoras, who proved it was true. So example 1, how can you show the Pythagorean theorem using a geometric model? So it says, draw a right triangle on grid paper, draw a square on each leg, and on the hypotenuse using a ruler and protractor. Cut out the squares on the legs, then rearrange and cut those two squares as needed to fit them on the square of the hypotenuse. What do you notice? Well, try it several times using different right triangles. So we're not going to do that, but you can see back from the diagrams here, if we cut these out, then here I've got 16, which would take up this part. Oops, what's happening? That would take up this part of Sam's area, right? And then I could take these 3 here, put them here, right? These 3 here, put them there, and then cut up these into ones, and they would go 1, 1, 1. So you can see how they would overlap and be the same. Okay, so in the next one, how can you tell if triangle WXY is a right triangle using only a ruler? Okay, so you need to get a ruler out and measure those sides. So you can pause the video if you need to, but you're going to measure them and just label them on here. So this looks to be the shortest side. That's 3 centimeters. Then if you measure this, it's 4 centimeters. And this, it's 5 centimeters. So they're 3, 4, and 5 centimeters. What is the sum of the squares of the 2 shorter side lengths? So sum means add of the squares. Well, that's going to be 16 plus 9 is 25. What's the square of the longest side? Well, 5 squared is 25. So notice they are the same. What does that mean? Well, that means that it's a 90-degree angle in here. It forms a right triangle. So they are equal. Oops. Therefore, it is a right triangle. Okay, and then I think you get into some practice, right? So you do that.